Hey everyone, this is the SIG Auth meeting for May 22nd, 2024. Looks like we got a handful of items on the agenda. We don't have any announcements. I guess just as a reminder, I think enhancements freeze is in about 3 weeks. And I think PRR is about a week before that. So if anyone has anything, that would be a good time to get it in by. So I guess we can get started. So the first item on the agenda, I had added this like last week, but I think or last time we didn't get to it. And I just wanted to ask folks on this call if they had any concerns with kubelet reloading files on disk for I think it's serving certificates. I think I actually can't remember if it's serving search or client search. It might be client search. No,
I thought it inherited client cert reload through client go stuff.
Yeah, sorry. I think it is serving.
Okay.
It's serving when it's this file. I keep looking at the wrong file. It's serving when it's not using the CSR API to do rotation. Instead, some other process is just updating the files on disk. So I think for me, conceptually, it seemed fine. I think one of my open questions was that the existing TLS bootstrap feature is behind a feature gate. And I didn't know if this should also be behind a feature gate. I mean, I mentioned it to the person and then they proceeded to add the feature gate, but mine was a question, not a suggestion. I don't know.
Remind me why we haven't graduated that yet?
That I also don't know.
Because there's no in-tree way to verify the host name and IP the kubelet is requesting is okay for it to request. So we don't really have, we have nothing in kubeatom that can, like, in a principled way, approve these certificates, and it's very hand wavy how, like, what advice we would give to people outside to approve. Sergey started a KEP to like capture the current state in a KEP. It kind of got deprioritized. That was like the main question, I think. Like, what do we want to try to improve that or not? What do we tell people to do to approve these things or not?
I propose we don't try to fix it. Just like when you think about what it is you check, right? You look and make sure, like, yes, this came from my image. Yes, this is the node that I expect. Yes, this is the IP that I gave that machine. I'm not seeing the Cube project as the spot that says this is how I verify those things.
I mean, the cloud providers do like node metadata attestation, right?
They can, yeah.
Okay, so I think
I largely agree. That's why it got hung up. Anyway.
But okay, I think Sergey gave up on it, and Kevin, I guess, picked it up. So let's see here.
I guess the question about a gate for reloading the non-TLS bootstrap case. What could break if we start paying attention to updates to that file?
So you could incorrectly change the files in non-atomic ways because it's much easier to change it. So you could cause your kubelet to freak out for a little bit while it gets a partial something. Though I think it should correctly just ignore it.
If it's invalid, it would ignore it. If you, it's a serving certificate, so it's a single cert, right?
Well, it's public and private key pair, right? So it's one file.
Within one file,
It's 2 files.
2 files.
So you have to be careful how you do the reloads to be principled and actually like, put them in the directory and then swap the symlink of the directory and not the.
Do we make sure the cert and private key match?
Yes, because we
Okay.
tried to load them together.
Okay, then an error there would keep using the current one. I don't know. I don't see a strong case for gating it off, but if someone wanted to, just out of caution, like as an escape hatch, I wouldn't object. I don't know.
Are they using the same code we use in the QAPI server? If so, I see no reason for a gate.
I don't think they are.
No, they are. They re-implement the kubelet interface using the code that David wrote a long time ago. And then we updated. So this right here, this implementation is literally just using the thing David wrote a long time ago. So, and it's a pretty clean implementation, right? Like the current method is just the load method.
But I thought David was asking, like, are we using secure serving structures and things?
I was asking if we were using the same thing. So, okay, I can see that caution being wanting to be applied here.
Oh, I see. You mean like literally the same, like.
Yeah, if it were the same, you'd look at that and you'd say like, okay, we've been using that for 3-4 years.
This is the same building blocks, but it's wired in new.
Yeah.
I'm kind of ambivalent.
I'll leave it to your judgment, Mo.
Yeah. Okay. All right. My judgment says just be obnoxiously cautious.
I think this is in the, like, we think it's fine. We've tested it. As far as we can tell, it's fine. If it breaks, here's your out.
Yeah. So are we fine saying from like a SIG Auth perspective, this change is structurally valid? It reuses the code that we have used for a long time in a new way. With a feature gate, you can back out of it. It has tests, at least unit tests. I don't know how you would integration test the kubelet other than painfully. I guess this comment, are we okay with just deferring the rest to SIG node?
That seems appropriate to me.
Agreed.
All right. If anyone else has anything, I can go on to the next one. So let's see, Patrick, you're here. So I added this because Jordan, you had tagged us on this specific part of the DRA cap. I think I had commented that to me, this sounds like a scenario where we should try to come up with some strategy for having service accounts that can be scoped to a node in terms of authorization and not just like a binding. And we have some stuff today with the whole validating admission policy that can let you do certain things for writes, but not for reads. I don't know.
So originally the scope of this was, my understanding of the scope of this was, kubelet is getting some status from some drivers on the node and wants to pass through or aggregate that status from those drivers into API objects to surface like DRA resource availability or status or something. And we want old kubelets to be able to pass that information through faithfully without dropping fields or needing to understand if new things get added to the DRA status API and there are new versions of plugins that understand new versions of the DRA API, it would be nice for kubelet to be able to just pass through those statuses like opaquely.
Yeah. I think that's a fair summary. Yeah.
Okay.
And it's not just passing data from the plugins through kubelet to the API server. It's also the other direction.
Okay.
Some of the data that
That
It's,
was
it's both. It's
not
both. It's both reads and writes. The write part is for the resource available, resource capacity information that comes from the plugins. But
Mhm.
then when a claim has been allocated, there is something in the status that basically tells the plugins what to do with the claim. And that data might also be version dependent on the Kubernetes, on the DRA API. And it might be, or it will be, that in the future, we change that status or that plugin state, this claim status that the plugins need to read. And this needs to be done with a version supported by the plugin and not necessarily the version that kubelet understands. So it's both, it's bi-directional. Both directions need to be supported. And yeah,
Is
the current approach just doesn't give us the version SKU support that we would like to have.
is the call to the plugin or the read part from the plugin more like CSI, where it's, you know, there's sort of stages and like here's information inputs to the plugin at specific points. So here's information, do a thing. Here's information,
Yeah.
do a thing. Or
It,
is the plugin like watching and reacting to real-time changes and updates?
no, the read part, well, for the resource claim, it would be on demand when there is a claim that needs to be handled on the node because a pod is starting on the node that needs to claim. Then we currently do a read of that resource claim in kubelet and pass the data on. That read would need to be in the plugin. So it wouldn't be watching all claims. It would only do that once there is an actual need to do something for a specific object.
Okay. I mean,
Or
we kind of have two models normally. Like one is a very constrained API surface for something like CSI, which does not have visibility to the REST API. And it's just being told, like, here's the information you need, do the thing. I'm going to ask you for the information about a particular thing. So it's a very constrained surface. Whether or not we can provide a constrained surface with
not
kubelet sort
anytime
of
soon.
opaquely passing things through in both directions, that's one question. But opening it up so that these DRA drivers now have full access to the REST API to like do who knows what, reads, writes, watches,
But
like
that's not ideal either. That's
yeah.
why this REST proxy is filtering the REST requests. So it's filtering out, basically it has an allow list of requests that it lets through, which is scoped to resource claim, resource slice, resources. It can even limit the method. So it's only read for resource claim, for example, read write for resource slice. And then the version is chosen by the plugin, and kubelet doesn't get in the way. This is the approach that I had implemented. The advantage of that approach was that these REST requests are done by kubelet using its own credentials, and that makes the node authorizer apply its additional checks. So a get for a resource claim, for example, at least if it's a normal get, is limited to what claims are needed on the node, which is kind of hard to determine because there is not a single field in the resource claim object that could be checked. It needs the full dependency graph from pod to resource claims, or from node to pod to resource claim to determine that the resource claim is needed on a node. So this is supported by the node authorizer code that I wrote. It was used before for kubelet, and now it would be applied to the kubelet plugins because they use the same credentials essentially.
David had a question.
Yeah, I was listening to the like we can identify who is requesting. That sounds a lot like kube API server authentication. I was listening to the We can decide whether a request should be allowed or not. That sounds a lot like authorization. There was a comment about getting it back in the format as expected. That sounds a lot like version negotiation or version conversion, also in the QAPI server. How big is the gap between what you need and using the credentials of whatever provider, the resource provider that you're looking at, to request this information? Is it solely remaining? Is the only thing remaining the resource claim metadata with the mapping?
I don't know. I don't know exactly what kind of authorization methods are available besides the part that I've already touched. So I know the node authorizer because I've extended that at some point. I don't know any. I've seen counter proposals that say that this can be done differently, but I have not had the time to explore those alternatives. And I also don't think I will have time. So if we think that this will be possible at some point, what I would do right now is to basically just tell people, okay, you need to have a service account configured for your daemon set, and someone will come up with a proposal how to lock down that access so that it is comparable to what is kubelet authorized to do. But I don't have the knowledge or the time right now to dig into that aspect and figure out where the gaps are or close those gaps. So that's why I look for help from you guys to tell me how this could work, whether it can work in a reasonable time frame, and well, perhaps even help close any gaps that are found while someone tries that.
I will say reusing kubelet credentials does rub me the wrong way, knowing that there's going to be multiple of these resource providers. There are likely to be use cases for subdivided access, and leaking the original goal of I want to be version independent becomes somewhat more challenging as you couple yourself with a built-in authorizer that you're making code changes in.
Yep. I see that point. I agree. It would be kind of limited to what kubelet knows about right now, which gets us some releases in the future, but there might be something that is not covered by the current authorizer in kubelet. So if there is a better approach, I'm all for it. I just don't know what it looks like. Regarding timelines, we are now talking about another alpha of DRA in 131. So I don't see it as a pressing concern that needs to be solved immediately, but probably for 132, it would be nice to have a definite answer on how this limitation of access for kubelet plugins could work. So this year.
We want the ability to limit daemon set pods to sort of intersect the permissions of a daemon set pod and the permissions of the node on which it's running. Like that is a thing that has come up over and over and over. And so this seems like another instance of that, and we've never really had a good answer for it. I don't think putting a proxy in the kubelet is what we would do if we're gonna do work to support this. I would rather see us use that time and energy to make progress on the node scoped daemon set.
Yeah, major plus one to that. I think we've talked a lot about this in the past internally. Like it's kind of a tough choice right now between either getting node restriction or having to be like super careful with what you do in daemons that just use native pod identity.
I'm curious about the subdivision question. So assuming that there was a way to express, I've got a daemon set service account. Here's the permissions I want it to have, but I want those to be intersected with the node that it's on. I think that would get parity with what you have here, where you're limited to what the node can do, and then there's like further limitations to just the resource claim and DRA status objects.
So if we could make the node authorizer apply to daemon set service accounts, I think that would get us a long way to feature parity what we have right now.
It gets us node scoped. I don't think it
doesn't
gets a subdivision. If you had two drivers on the same node.
Yeah, that's true. That is something that is currently kind of handled by Kubelet because it does additional checks based on its understanding of the data. I don't see that as a big problem because these plugins are so privileged on the node that effectively there is no real security boundary between them.
Is the information the kubelet is making decisions based on in the API objects such that you could use like a validating admission policy to subdivide if you cared?
I'm not sure because some of this is indirect. Like, are you allowed to update? This is the new thing that is actually that came up after I did the REST proxy. We have traditionally not had information that a kubelet plugin needs to store in a resource claim, for example. But some recent investigations around network and using DRA with network hardware point towards some people wanting to post, say, an IP address in a resource claim. That adds the right part for a resource claim, and only for the part that is nominally at least owned by that driver. But yeah, I still think that the node boundary between kubelet or kubelet plugins on different nodes, that would be, in my opinion, sufficient.
I was more asking for the subdivision piece if there was identifying information in the claim so that you knew which driver it was related to, so that if you wanted to guard an admission that only this driver could update claims for that driver. Is that information present?
It might be multiple claims, but in principle, that information should be there.
Okay.
So how is kubelet identifying? Assuming that's proxied by kubelet, how is kubelet identifying the driver before it proxies the request?
That's because the claim status has an allocation field, or basically a larger structure, and inside that structure there's a list which lists the driver names that need to do something. So it's a bit nested. It's not a top-level field or anything. And
are
it's
multiple
not just
drivers reporting status into one object?
Yes, because we have a resource claim that conceptually binds together different devices that need to be, say, or need to share certain attributes. And we are currently using the claim as the level where we can do this correlation between different devices. So it is more than one driver per claim, potentially providing different pieces of information for the status. This hasn't been formally standardized yet. We don't have this right part in DRA at the moment. It just seems likely that it will come at some point. So we haven't even decided what the fields look like, whether they are formally identified with a driver, or how they are identified, or how they are related to a driver. It might just be an IP address field in the resource claim status, and then there is some implicit assumption that there is one driver that knows how to update that field and does it.
Okay, I guess I'm confused about like what parts of the API are relatively well understood at this point and which parts are still evolving.
Everything is still
evolving.
Everything is still evolving. Tim has basically triggered the entire redesign or re-evaluation of the API. We are kind of homing back on what it was in 1.30,
Yeah.
But
Understanding which actors have to write and which ones write independently would be helpful in giving advice about
it's
authorization
clear.
strategy.
Unfortunately, that part is really, really new. We just came up as part of this new, this whole working group that we started around use cases, who's doing what with DRA drivers or might do something with DRA drivers. And now finally, some people spoke up for network hardware.
Okay.
And they raised, for the first time, they raised this issue with, we want to post some data into the status of a claim.
Yeah. If the drivers are essentially running as root on the node, then maybe like trying to draw security boundaries between them is, for like API writes they're doing, is not useful. But I still think preventing accidents is useful. Like, even if it's not a matter of trust, a matter of a bug in one controller driver can wipe out, destroy information from another driver. That seems very likely to happen, actually. So finding ways to protect against that.
I'll give a simple example. It's extremely easy to clear fields. Even if you trust these actors to do it, if the API gets bumped and then one of the drivers updates to use this new API and writes it, and the other driver does not update and does not use server-side apply, an update from the unmodified driver will clear the fields the other driver was using.
Yeah.
And I won't admit to having produced this error anywhere, but it is infuriating when it happens to you. So if we can find a way to prevent that, either with the API design so that they aren't writing to the same object, or with some kind of authorization check, I think the API design is a better choice because it prevents you from getting to a state where something is just repeatedly denied. But finding some way to do that is.
I assume we want to get away from kubelet proxying this, because that'd be the third option, right?
Yeah, that's where we started.
Yeah.
Like, we're not in favor of kubelet proxying. Finding a way to scope, if these things have to talk directly to the API, and it can't be a constrained surface like CSI, where the kubelet handles all the communication, gives them what they need, and
I was thinking about CSI node.
Yeah, so if it can't be that, and these things actually do need to talk to the full API, then finding a way to scope them to the node is what I would want to see. This is like one more use case for this, as if we didn't have enough already.
For this being like some sort of nodes, like daemon set that is designated as getting the node restricted permissions of the kubelet.
Correct. Yes.
I like the phrasing of additional restriction, where it is the daemon set has to have permission to begin with, and then it's further restricted, as opposed to you just accidentally inherit a bunch
of. It's a way to tell the node authorizer and node restriction admission. Any you have an opinion about, also enforce it for this request.
Right. It's like making node authorizer an upper bound on the.
It's an intersection
permissions. Yeah, and it might work. So like this, I think, is all APIs that are going to be built into core. So probably works, and are kind of node associated. So that might be constrained enough for us to like extend. Maybe it's like a good first use case for that daemon node.
Yeah, where we always ran into problems before were, what do we do about custom resources that you also want to write node partition rules around? Like, I've got a custom resource and I only want things from node X to be able to update instances of my custom resource named X, or where some field has node equals X. And like, it very quickly moved into like cell evaluations or JSON path,
or like we had some ideas around like post read checks in Kube API server that were kind of wild, right? Like none of it was straightforward.
for rights, I actually think validating admission policy might be the way out for that. Like, if you got a custom thing and you want to manage it with a daemon set,
Yeah.
you've got an extra field in the daemon set user info that tells you what node it's on. You can write a validating admission policy to match that attribute in the user to whatever field or name you want on the object. Like, I think that might be a reasonable path forward.
I think that technically
can-
works in some of those cases. There's a UX question on like how easy it is for everyone to start writing policies like that.
I'll settle for possible first.
David's got a PR open that shows it. It's not necessarily obvious, but it is possible.
Yeah, it turns out it was less obvious than it seemed to many. So it's good to have the example. On the read path, I do look forward to seeing what people do with the ability to intercept or to make authorization decisions based on label and field selectors. And I would like to imagine someone developing a really cool authorizer that did what we needed there for custom resources.
Is that coming on the read path, like in like a cell programmable authorizer? Or
No, just the concept of that will be added to authorization from David's KEP, but the actual act of authorizing using that metadata will be up to however a webhook wants to do it, because that's the only place that...
Yeah, it makes it possible for someone to develop something to show us like, hey, here's an API that can do this. It's understandable. Here's how you would use it. Here's how CRDs would use it. Here's how it would help the node use case. Whereas today, it's just not even possible to show.
would we consider exposing that anywhere in the API, like some kind of conditional RBAC binding or some other new configuration that lets you just write, like similar to validating admission policy, that lets you just program the built-in authorizer?
I do not have preconceived notions about what it would look like. I really am focused on make it possible, see what they build.
Before we kind of get off this topic, I wanted to ask, so like David, you mentioned you were like, pretty adamantly against mounting the kubelet credentials. And, I agree with that, at the overall level. But Patrick, to your earlier point, if all of these things are effectively root on the kubelet, they could always use the kubelet credentials if they wanted to.
Correct.
Okay. So if we're building this stuff, at least from the DRA perspective, for just avoiding mistakes, which I think we should have just for that in itself, until whatever we build exists, isn't it better to recommend to use the kubelet credentials and get node authorization restriction instead of just having service accounts that don't have any restriction?
Is that technically possible? Do people know how to deploy a daemon set so that it gets access to that kubelet config?
Oh yeah, people host mount all the time, and
okay.
They
so you need to know that probably need to make some assumptions about where that config file is, right?
Yes.
But yeah, that seems possible. Yeah.
That doesn't mean that I think it's a good idea, right?
No,
like, that's me.
It's a
admitting
stopgap solution. I see it
far,
as a stop. Yeah.
far from the best thing, but you have a really tough choice today, which is between granting cluster-wide permissions to daemons or node restricting them to prevent node to cluster escalations.
I think one of the choices you have is to say, I'm going to node restrict you for updates and I'll let you read anything. And I would say that is strictly better than...
How do you do that? Like, node restriction only supports node identity.
Right, a validating admission policy.
And we have the example that shows you how to do it.
Oh, with just the node binding on.
Yeah. So I would say, Mo, go ahead.
You give it wide access. You pair it with a validating admission policy that implements the node restriction.
And I see that as far better than changing the node authorizer to try to accommodate each of these. It will let us see what permissions are actually have. And the gap is that until someone develops something to restrict field selector permissions on read permissions will be broad. Is that perfect? No, but I think it's much better than modifying the node authorizer and reusing those credentials in a way that we will not be able to take back later because it will break existing deployments.
Let me be clear. My question wasn't let's modify the node authorizer and tell people that's the path forward. I meant until there is an actual path forward that we like, what do we tell people to do right now? Like they're gonna go play with this stuff today. But to your point, since this is all brand new, I think I like the idea of if we, I mean, maybe this is what you put in your cap, Patrick, right? Is you come up with the most reasonable validating admission policy that would work today.
I would like to keep it out of a cap, to be honest, and just make it guidelines or suggestions to a DRA author, because the cap is already complex. I don't want to pull in anything that could be a separate cap or some separate documentation that pulls pieces together that already exist elsewhere, if it doesn't absolutely have to be in the cap.
I mean, I think the read part is very simple. You just give them broad read access, and the write part is where the meat of it is, right? So you just have to at least give the validating admission policy as the example.
If we are providing the permissions, I think the burden is on us to also provide the admission policy that makes it safe. If we are not providing the permissions, if we're just providing the API and we're counting on them to, like, random DRA driver author to provide an RBAC role that grants permissions, first of all, they're going to write a terrible one that just gives global read write access to everything.
I'm all for having good documentation for this and giving them exactly the information and the guidance they need. I just would like to keep it out of a cap, if that's acceptable, or have some expert guide me towards writing that cap update and make sure that it's accurate and works.
I mean, your cap could just say that you're going to document the validating mission.
Yeah, that is actually what I put in one of my PR on this pull request comment. If we think that this is the way to go, then I'll just put a note into the cap that says there will be documentation provided as part of the instructions for DRA driver authors, and watch this space or these examples for more information. And that would be in the cap. And then in that other place, we can use the DRA example driver to really give a good example of how it should look like, and people are expected to follow that example.
If the validating admission policy is the implementation detail, and the KEP, as long as the KEP describes there is information in the API that an authorization or admission policy can use to make this decision to scope to the node, and then our example implementation shows here's how you can do it, that seems fine.
Yeah, okay. Yeah, that's the way forward for me for 131 then, and in the next few weeks till cap freeze.
Yeah, I think that's aligned. Like even if we did go build the daemon node restriction general thing, you'd still have to turn it on for specific daemons. So having to write like an admission policy that restricts writes is more or less aligned. Like there's an action required per daemon either way.
Yeah, our example, once we have the node scope daemon, our example could update and be simpler.
Right. And more comprehensive, because it would cover read restrictions as well. If we that thing.
Yeah. The one note about mounting in kubelet credentials is that it is absolutely not portable. So
yeah,
you could not give an example that would consistently, reliably work. In addition to just being icky and we hate it, it wouldn't be portable.
Yeah.
Okay. I have node scoped service accounts on my eternal list, like medium high priority. I'm looking at it right now. It never is at the top, but it's always like well above my medium priority line. I would love to see progress made on it. If someone has a bee in their bonnet and time, I'm happy to like repair on a design is just never at the top of my priority list.
Yeah.
We have so much stuff we would migrate to that like immediately.
Yep. Like it's up there. If this is a reason to do it, and it's like Jordan said, we've always run into the hard stuff trying to support custom resources or like other resources that aren't like implicitly bound to nodes, like config maps that aren't mounted in any pod, but like might configure some node daemon or something like that.
You're gonna love my topic.
Adam's like,
Ready. All right. We only have 15 minutes, so
Yeah,
might as
shall
well
we move
talk about Adam's thing now. So Adam, do you want to introduce?
Sure. This is, I guess, a feature that has been baking a bit in OpenShift for quite some time, and we feel it has a better home upstream in Kubernetes than just having it be an OpenShift thing. If you scroll down a bit, Mo, this is actually going to jump a little bit into what we were talking about before, or we'll very quickly get into this territory. And the idea is to basically have a mechanism for sharing a secret or config map across namespaces in a way that we are controlling access to those using Kubernetes RBAC. So the sort of concept we have right now is we have a CRD that built actually two shared secrets, shared config map, where the resource owner declares that some resource is eligible to be shared. And then it is up to most likely that same resource owner to define which kind of target namespace and service account should be allowed to access it. And then once that is set up, any pod can then mount it into the container using the CSI volume mount. Now, there are some problems with the current implementation right now. Mo and I had a bit of an interaction on Slack related to it. First, there's quite a few OpenShift isms in this that would have to be taken out if this were to be brought in as a Kubernetes SIG subproject. That's pretty obvious. The other one is that right now, since it's still kind of preview proof of concept, is the driver currently has access to all secrets and config maps, and that's going to be a no-no. We already have it on our roadmap to, well, because of that conversation, Mo, we're going to get rid of that. So part of the creation of, in addition to creating the secret or shared config map, that resource owner would also have to give the CSI driver permission to access whichever resource that they're going to give. That helps a little bit, but getting back to the prior conversation we were all having around node scoped access, it's not perfect. Since it's a daemon set, CSI daemon set, any node will have access to whichever either secret or config map is shared. And in an ideal world, we could scope that down to whichever node the pod is scheduled on. That would be kind of ideal, but I think as you had discussed at length, that we can't really do that today. The other thing that Mo brought my attention to is reference grants from last KubeCon, and that this kind of like idea might be a good candidate for adopting reference grants, and that might actually eliminate the need for this shared config map custom resource. So that's where we are. We're wondering if you're interested, if if there's a next step here, or how we continue the conversation.
I had one question about like the user granting access to the CSI driver. Will the user know the identity of the CSI driver service account? That seems like something they would be unlikely to know, or it would be hard for them to discover and it would be a little weird to like tightly couple lots of individually granted permissions. Like from an admin perspective, it's like, oh, I want to run this driver in a different namespace. It's like, oh, I just broke all the access.
Right.
Like, I broke the identity. That sucks.
Yeah. So that's part of another, I guess, OpenShift-ism of it today, is that it's tied to the platform right now, and so that's something that OpenShift has more control over. And as an upstream, we have to start thinking about this can run in any namespace, and the service account name could change and things like that. So
I'm not fully convinced of that. So for Ingress today, I have to grant access to my secret. Do I think it's invalid to have to grant access to my secret to know which user I have to grant it to?
You don't have to grant access to a secret. Ingress controllers have full read access to all secrets.
That depends on how you wrote your Ingress controller.
99% of them do cluster-wide watches. They don't do individual watches.
I mean, I guess I don't see an issue with saying, you know what, this is like Ingress. We can do the bad thing, but realistically, you should know who you're granting access to.
There's three actors there. There's the user that wants their thing to be serviced. They rarely know the identities of like random system things. There's the controller author who should do the right thing and do individual gets and individual watches instead of global list watches. And then there's the admin who's deploying the controller and giving it permissions. And like if the controller author was well behaved and didn't try to do global list watches, then the admin has options for how they grant it permissions, right? It's tedious to grant lots of little individual gets, but they could do that. But expecting the end user to know the identity of the controller, like there are plenty of examples where the user's like, I want storage. Like, I don't know what the default storage class on this cluster is. I just want, a persistent volume. And here's my encryption secret. Which CSI service account should I grant access to? Like, it seems weird to push that burden onto the end user when it's actually the cluster admin.
Let's stick with the one we have today, Ingress. What do you advise your users to do today? Or do you have one that just has global read access on secrets?
I don't actually know.
So I'll say, like,
probably global read access.
We solve this by having an indirection, right? Where you go and you say, I wish to reference this secret, and we individually grant the permission and we individually do the list watch.
So every end user has to grant permission?
We know which one it is. And that's what Adam is saying. Like, we know which one it is. We can do this easily. But we also can look and say, like, you get a choice, right? Do you want to grant them all? Still a choice here. Or do you want your users to know which identity it is? That's the alternative.
By making the end users grant to a specific identity, that identity becomes part of the API. And that's not something we've traditionally required.
We have required it. You just don't know if you do. Like, so like either you require it for your Ingress today, or you've granted your Ingress global read rights.
Or
not a whole.
Admin writes something in the middle that says this is referenced, therefore I will give permission to the Ingress controller, and you don't make the end user worry about it.
Right? And that's where my mind actually was going, Jordan, where it's like, well, maybe in theory we have a controllers watching a shared secret, shared config map that is doing that, but I think on many kube deployments, you would have to then give that controller global read permission.
Yeah, it turtles all the way down.
It's constraining the problem then just to the nodes where that controller is running versus every node that daemon set is running.
But no one said the controller has to run on a node, right? The controller can be just like KCM and not run on a node and run off the cluster.
Or run on control plane nodes or trusted nodes or whatever.
Right.
Yeah, making the end user know the identity of the controller satisfying the API seems off to me.
Yeah, it's only a requirement because we don't have an API to support it today. right?
Yeah, I mean, looking at the referential auth stuff, right? That's where the reference consumer concept comes in, is to indirect the actual subject from the thing being done, right? It's so that you don't have to know.
Right. And just to level set, you guys are completely fine with doing this on ingress because the ingress just reads all the secrets.
I'm not fine with that.
Okay.
I were literally trying to build referential authorization so we don't have to do that.
Okay.
The three, I see there being 3 actors that don't have all the information, and it sounds like you're flattening it into 2 actors where the user who wants their secret to be used to secure their ingress knows the identity of the ingress controller and is happy with that being like fixed in time forever and a well-known API type thing.
Right. Like it's
I'm more pointing out the difference in standard, and I'm okay with said difference, but it's definitely there.
there's a desire to keep the service account name as an implementation detail of the controller that actuates a resource. Right. And that is
So that is the
that
defense
is
of reading all secrets.
incompatible. That's incompatible with the desire today to subdivide or to grant granular access, which requires exposing that name today. Right. So you can do it today. It's just a pain in the butt. And it's maybe an anti-pattern if we
I
look at
mean,
it.
I would even go further, right? You could technically do it, but it also requires the controller to support that, which most of them don't. Is the point, right? Like even like really important and well-used controllers like Cert Manager don't support that, right? And it does have read-write access on all your secrets because it's filling them out for you half the time, right? So if like one of the de facto standards in our ecosystem doesn't do it, then like who actually does it, right? The tooling doesn't exist to make it read.
Is that because of like the most controllers just list, or like
Yeah, most controllers need to act on a set of unknown namespaces, at least at startup time. So the way they do that is the cluster-wide list. And based on whatever they see when they start up from all the resources, they're like, oh, this is the secrets I care about. So they act on those. Okay. The KEP David has today for the scoping based on labeling field selectors at least gives us some path forward there. I'm like, well, you need to label everything like this because otherwise the controller won't be able to see it. At least that's technically vaguely better than the approach right now, which is still go crazy at all.
Will immediately become an API.
I will take that API over what I have today, which is everything.
And I would take that API over pinning to a particular identity. Like that lets you move the names.
It gets you to exactly the same spot, Jordan. Like I have an ingress satisfied by this. I either named the controller or I named where it lives.
It's not the same spot. The labels can keep working even when I change the namespace the controller's running in or start running it off cluster. That's not at all the same spot.
Neither. The identity doesn't have to be the namespace where you're running a controller. It is just the namespace, or sorry, it is just the name where the thing runs. It's going to be an identity of some kind. If you wanted to satisfy it with a different thing, you wouldn't be able to, or you would end up saying, yeah, I'm really this thing even though I'm not.
there's a difference between like in referential auth, the administrator specifying specifically which resources a controller is responsible for versus somebody just whoever owns the controller just creating a conditional binding specifying which labels apply to it, right? Maybe it's a subtle difference. but there's maybe a UX question there in terms of how people are managing like what is responsible for what.
I mean, this is sort of what we've been going around with, like the pragmatic first step of label selector authorization. So you have that building block. Now, what do you do with it? Do you tell users label your stuff this way, and then figure out a way to grant that? It's not an RBAC yet, but figure out a way to authorize a specific label, and like make users responsible for managing that label? Or do you have a controller pay attention to what is actually referenced and then go apply labels to things in order to grant access? Like one is making users manage the labels, and I agree with David, it becomes like an API at that point. The other is a controller reconciling that as to grant permissions to things that are referenced only.
I think it's worth. I prefer the
support
reference.
both
I won't
methods.
pretend. Like I prefer the reference, but I am aware of what will happen.
Yeah. We're out of time. We didn't get to the next about Health Z. I would encourage people to take a look at that. That is a proposal around a topic we discussed in the past around how to give a path to scope down anonymous auth for consumers that still rely on it for things like kubelet health checks or load balancer health checks. Anyway, I haven't looked at it yet. I will be looking at it shortly. If you haven't looked, please do.
My 2-second feedback is I don't want anything hard-coded. I want to be able to specify exactly what I intend to have. So that way, for example, I can have not just those endpoints. And specifically because I don't need those endpoints, so that I don't have those. But I'll push that one to 2 weeks forward. That way we can talk about it.
2 weeks from now will be our deadlines. So we actually, if we want to see anything happen for 131, we will need to iterate on it between now and next month, which is fine.
All right. Bye all. Have a good week.
Bye. Take care.